Okay, the next presentation is about, it's an update on the status of the HP-41 MAXX module. Last year, I introduced the MAXX module that is made by Monte, and there was a development in the past year. So this is basically the same presentation, but updated for the new functionality and the differences. Okay, I want to thank Monte, Angel, and Robert for their help, and because I send a lot of emails, questions, and things that I don't understand, and sometimes I'm struggling. So, what's the MAXX module? The MAXX module was designed. Monte took 41CL technology and they put it in a module to be able to use it on any HP-41 standard. So, and it's trying to put the 41 to the maximum possible to add everything that you can on the system. So what it does, it adds memory module. If you have a 41C, it adds a quads module to RAM. It adds, depending on what you have, it will add up to 2 extended memory modules, 1 extended function, 1 time modules, and it's going to also add QROM and expanded memory. And I'm going to show that. So this is the same thing that I did, but what's the target? You can have, if you have a standard 41C, it's going to add up to a quad module or 4 single memory module. If you have a CV or CX, it will not do nothing because you already have it. Okay? If you have a C or CV, it's going to add an extended function memory modules to it. If you have a CX, it will not do nothing. Okay? If you have any of the other one, it's going to have 2 extended memory modules. If you have a physical extended memory modules plug, it will activate only 1. So it senses what's there and adds what's missing. Okay? Same thing for the time module. Okay? It's going to also add 3K register RAM. So the HP-41 standard can address up to 1K of registers. That means that you got 320 registers on a CV and CX. You got also the extended memory that adds some register before and a lot of register after. But you can address up to 1,024 register, not all usable, but that's what the 41 can address with the standard 41C. The CPU can address 4,000 registers. But HP never pushed that to that limit. So, so think about it. 4,000 registers times 7 bytes. That's a lot of memory for the calculator. So Angel, not Angel, but the Monte, what it's doing, it's adding those missing registers, 3,000 registers to the 41. And also, it's adding a 12 bank of 4K of QROM. QROM is basically RAM into ROM space. And then you can use it as RAM. Okay, so the thing is that when you do ROM development, or if you want to do using some special module that can use those RAM as you could put your program, you could put them into that place and run it from there as if it was you created your own ROM, but you do it in RAM. It's basically in the 1980s, it was called an MLDL box, a Machine Lab Development box. And it has its own MAXX ROM. So that's what it does. Okay. So when you put a MAXX module inside, depending on the port you're gonna plug, it's gonna add, if you need it, the timer. If you have a CX, it will not add it. the X function will always be in the lower page of the port, and the MAXX module will always be in the upper page of the port. So depending on which port you're going to plug, that's where it's going to be. If you have a CX, only this one will not be activated, this one will not be activated, only this one. So this port will become available for something else. This page, sorry. Okay, that's what I explained before. This is a table that showed that. Depending on the configuration that you have here, you got 9 different configurations possible, and the type of memory that you have, and where it's going, depending on the configuration at the bottom, where it's going, the MAXX module in blue will add its own memory to this. Okay, you got a function in the MAXX ROM that show you that what it has added to the system. It's NX MAXX module status, and it will report something like that. TXM with enable or disabled. So if you have a standard 41C, you got everything is going to be enabled. A CV, the main memory will not be enabled because it already has it, but it will activate the time and the extended memory and function. And on the CX, only the 2 extended memory will be added for that. So you got, this is all the module, the position on the table, and then the status. So if you have it, you do that function, and you will know right away what's being activated. I'm going to pass over this because my time has been cut. So this is how you, like a procedure when you start the module and you want to see if everything is working correctly. Now, expanded memory. In the 41, you got standard memory. You got the extended memory that was coming from the extended function and memory module. Monte add the expanded memory. This is coming from the 41CL. CL has this, okay, and we use it for all kind of stuff. So that's coming. So this is we adding the 3K memory register over more than what's possible on the standard. So this is the first K register. And then you got the status, the X function, the main memory, the extended memory, first one, second one. You got some holes, but basically that's what you get. And here, the module is adding that, the 3 others. Now, you got some function that how to use those memory. You can use that as a backup. You can take your whole the 41 and do a copy here, okay? Or bring up the backup. You can have 3 41C full system as a backup, and you can swap. You could have like a setup for surveying and with all the program, and then do math for another stuff, and you back up and restore without having to go outside, just internally. Okay? You can also clear that. So those functions here will swap. You take that, copy this, take this, copy there. But normally if this is clear, when you're going to copy this over, you're going to have a memory loss because you're bringing everything. So you have to, but if you have a memory loss, those will not be loose. Now you also have function to copy or swap specific parts. You got 3 parts. You got the main memory that if you do swapping with the main memory, it will save the main memory and the status memory. Doesn't have the choice here and need to be done at the same time. You can also just swap the status memory or copy one or two or the other, or the extended memory, the 3 block of the extended memory. some example of how to do this. You specify the number, copy to the extended memory to the Y memory, and things like that. So it's pretty easy to do, to use it. Also, expand the first expanded memory, the block 1, there's 3 blocks. The block 1 can be used as data register. Instead of backup, you can use it as a data register. So this is giving you 1024 data register that can be used directly. Okay, so there's functions that's there that you can recall, store, and so on. Again, this is already available on the 41CL for years. So it's just that it has been brought up. Those functions has been developed by Angel. And Monte is using those ROM and modify a bit, but mainly using what Angel has done. And also, it has a keyboard. When you start the function, like if you call the Y recall, you go into an interactive mode. The interactive mode is depending on the key you're going to press, and those are key here, is going to switch between the different extension that is doing for accessing those expanded memory. And if you press recall and then you recall again, you're going to use a standard recall. But if you are in Y recall and you press stow, it will go to that function. So it's like a speed up things when you're there and you want to move. And then you can there's modifier that you can specify the 0 to 999, add to 123, have indirect with those registers, use status registers, and all kinds of things that you can do. So you can mix and match expanded memory with standard memory and have fun. So this is all the combination that you can have that's based on what you do and what's going to happen. And when you program with this, you will always have 2 steps in the program. The first step will be the command, and the second one will be which command that you're doing, direct, indirect, and so on, and is using some offset in a number to know which one to use. So in your program, if you see Y recall 001, that will show that you will see Y recall 0, direct is going to be 001, indirect is going to be 1025, and so on. So this is, if you look at your program and you don't understand, come this, and you go decode what you're doing. Also, you can save alpha. You can back up alpha to one of the status register, Y status register, and you can also back up and restore, exchange the stack. Also, you can also move Y data register and swap data register between sections if you want to do some management of memory. That's about it for that. Nope. Sorry. One thing here. I'm going to go back. Here, we got those functions here. We got 3 blocks. And we can use the status, the data register only on Y block 1. But nothing's prevent us to use that memory and then swap this to the 2 blocks and then use another set of blocks with data. So effectively, even if you have only the Y register function only works with Y memory blocks 1, because we can swap block content, we can have 3,000 data register available to do what's need to be done. So if you have data capture and if you have something that's doing data collection, you have a lot more data that was possible before. Yeah. 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 You can. Those function only works for the data register part of the expanded memory works only on block 1. But because you have other functions that can do memory management, you can swap block 1 with block 2. And let's say you're clearing block 1, 2, and 3. You're filling block 1, swapping 1 with 2. Then you got a new set of data register. You can fill it up, swap block 1 with block 3. And then you can have another set. At the end, you got 3 data sets. And then you can swap and do what you need to do. OK, the QROM part. The QROM part is it's how to use, for the 41, is native memory is ROM. It's microcode. Focal is interpreted by, it's a program running in microcode, interpreted the focal program, that's it in RAM, that it's part of register RAM. But for the 41, the register RAM is a peripheral, like the display, like a lot of the card reader and so on. The register RAM is main RAM. For the 41 is main RAM or ROM is a 10-bit ROM, not a 56-bit RAM. So the 10-bit, normally for the 41, all the 10-bit memory are ROM, not RAM. But if you have, in the 1980s, people were developing machine code, and they need to do it in RAM. So they were, you got the machine language development lab that was created, or RAM box, that was implementing 10-bit RAM, 10-bit ROM in RAM. So you could load, develop, modify, and so on in your program. So this QROM is that. It's RAM in the ROM space. So this is what it's explaining. Also, you got 64K addressable of 10-bit word. And out of that 64K, you got that divided into 16 pages 4K. So that's the basic thing and how the system operates. So the 41, all the ROM are based on 4K pages. And you can have multiple banks of 4K pages for the same address. So this is what I'm explaining. You got 16 pages, okay, and up to 4 banks. Some are using by the system, and you cannot use it. Some are available. So the 41 OS is using page 0, 1, and 2. Okay, it's not bank switching was adding way later, so it's not part of the system at the beginning. So at when the system was created, there were no page switching. So everything that was creating before 1985 or something like that, there was no back switching in the system. So this is 41 OS, CV or CX, different OS but the same pages. CX is using page 3 for the extended function and the time module and an extension. When the CX went out, that's the first time you see page switching. Bank switching, okay, for a page. Also, for the normally page bank switching is implemented at the hardware level by the peripheral, not by the 41 itself. So depending on the peripheral, it's the one with the behavior is defined by the hardware implementing it. But the normal behavior today, how it is working after, at some point there were an agreement between all the hardware maker, is that pages under page 7 and below are independent, and the one from page 8 to page 15 are port. So if you do a bank switching with a port, both bank will switch. Both page will switch banks. But here, only page 7 and page 6 are dependent. But these are linked. Okay. This is what I just explained. So for the QROM on the MAXX module, okay, you got function that allow you to activate a page as read-only, write-only, both, deactivated, all kind of stuff. So you can have a page that is write-only, and you will not see it. You can write to it, you can change the content, but you cannot see. Then you can change the access mode into from read-only from write-only to read-only, or read-write, depending on what you want to do. So those are the functions that are associated with that. You can also copy banks. If you have a ROM here, you can copy page 9, bank 3 to page 15, bank 1. So you can do ROM copy and management. So if you want to copy a ROM, you can insert a ROM, and you can copy it to where you want to, and you have an image. Then after that, you can remove the ROM. You can also transfer ROM image from tape drive or virtual tape drive. The modules support two formats. It supports eRAMCO format and ePax ROM format. So you can take a ROM image and read that ROM image to a specific page. Okay? Or take a ROM and save it to a specific page. So that can do. You can also change the content of a single cell by peeking or poking into an address. So how you do this is basically you specify, you can specify in alpha the address column, the content, and if you do an alpha x peek, it will peek into the memory and return you the content of that memory. You can do the same with poke, and you can do it in decimal also. So depending on how you want to do, you can read and write any cell into the 64K addressable. Okay, I'm going to use that. On the when you want to use a QROM, basically what you do at the QROM, you have 12 pages of QROM. You select a page that in the MAXX module, and then you're going to say that page I'm gonna plug it or take that page from the QROM and map it to one of the page here and one of the bank. Okay, so depending on what you want to do, if you want to, let's say, use an Angel ROM, Angel ROMs often use one page, 4 banks, and page 4 with a library. So you're gonna basically configure the QROM to say, okay, I'm gonna use QROM 0, map it to page 4. QROM 1, map it to page 8, bank 1, and so on until you have your setup. And then you can load the content of your ROM in it as read-only. And when everything is loaded, you change as a write-only. And when everything is loaded, you switch from write-only to read-only, and then everything becomes visible, and you have a new setup. It's the same thing as a 41CL. As a 41CL, you put names. You say, okay, I want to plug that ROM into that page. I want to plug that ROM into that page, and so on. And it's going to do the same. It's just that here it's a little bit more complicated because you don't have all the database and so on that you have on the 41CL, but it's the same principle behind it. What you will have in the presentation, if you look at it, I did a step-by-step mini how-to, but I don't have time now to go through it. But it will take a 41C or CV, and it will do, this is how to clean up, to put back the MAXX module QROM page like if it the first time you plug in it. So if you did something, you want to reset it, you have to run this, and that at the end, you will have the status of all the 12 blocks. That is not bank, disable, all in page 15, and so on. This is like to put it back into factory default. Okay? And then what I do here is I use lifutil with a set of utility that you can manipulate a lif file through the command line. So it works in Mac OS, Linux, and Windows. And I'm creating a volume, and after that, I'm adding ROM into those as lif file into the volume. And at the end, I have here I have a PPC ROM using the eRAMCO format in the file. So I'm adding the ROM. You can go fetch the ROM from Monte's site. Each month is publishing the latest version of the ROM. You got about 500 ROMs in it. I don't remember how many, but it's a ton of ROM. And then you can extract that and use that. And after that, here I'm using a second set of ROM from Angel. That's the OS6 ROM and the library for. Doing the same here. And after that, I'm connecting using that file with a pillbox and a peripheral simulator like PyILPer, and loading that file, and then this has become compatible. I can read that with a 41C, with a HP-41 with HPIL, and read those and bring that to the 41. So this is how you can load that with the command. Okay, so and at each step, you will see that those commands and where it's located, the status that it will give you. That's the, if you then loading the OS6 module with the lib4, what are those commands that you need to run? There's a small program that does it with the command that what each step is doing, and at the end, what you have. At the end, is after all that, I have the PPC ROM into all banks of page 12 and 13, and I have the library 4 on 2 banks of page 4, and the OS6 on 4 banks of page 10. So that's it. And I had the same for the 41CX. The ROM are not exactly the same, but it's the same thing. Inside the presentation, you got those lif files are already made. They are available if you want to use it. Yes. Make attention. Angel, when he did all his ROM, was for the 41CL. 41CL is using the HP-41CX ROMs. And when the MAXX module started to the development, you can put a MAXX module into a 41C or CV. So all the ROM from Angel didn't work. So he redid all his ROM to be compatible with the CX and the CV. But he had to make 2 sets of ROMs for each. Okay? So that's why I have instruction for the CX and instruction for the C and CV. It was a little bit different, not the same ROM image, but the same functionality. Okay? So this is why you got the QR41CV.dat. This is for CCV ROM image, the same thing for the CX. I've also had a table to map to the equivalent of the MAXX module versus the 41CL functions. So it's already available in some in the XPMM module, and in the XPMM module, the name, the MAXX name is this, and in the other module, the equivalent function is there. So you can, if you are used to this, this is the new function name. Some in blue are specific to the MAXX module and not available to the CL or vice versa. Also, I have the list of all the ROM file that's compatible with a C or CV, and the same ROM for the CX. So this is pointer for what you need to find all the information and all the file that you need if you want to do this. The module is going to be $135 if you give Monte a module that he will open up, use the connector, the shell to put his own module. If you don't, then it's $155. The module is in beta testing. The reason it's not yet out is because of me. I'm late in my testing, and I found something that I'm not sure is really a bug or just me doing bad manipulation. I need to validate that, and I don't have time yet. So it should be out soon, but probably before the end of the year or beginning of next year, but it should be very soon now. So that's it. I have a question? Everybody's asleep? Yeah.